So I'm Alexander Macholis. I'm Chief Architect for Cloud Computing at Interroot. You might ask yourself what Interroot is. No one really knows, even though everyone in Europe uses it. As it says there, we have about 40% of the internet in Europe. We just acquired EasyNet, so that jumps to probably about 60%. Lots of fiber, now about 80,000 kilometers, lots of data centers, and at some point, well, that maps to this. Not really good map, but that's our network around Europe and stretches to Asia and the US. And at some point, someone looked at this and decided to place cloud computing nodes all around. About 3 years ago, we built what we call Virtual Data Center, first version using Abico as orchestration. And almost 2 years ago, we deployed the second iteration with CloudStack, which now have 3 regions, which customers do use single sign-on through our own portal, Europe, Americas, and Asia, and 14 zones in about 11 countries. And I think the big differentiator that we have is that we don't charge for data transfers. People can just transfer as much as they want everywhere, and we don't charge at all. And about a year ago, we started talks with SolidFire about deploying full flash arrays. And now we have deployed them everywhere. They work really well. But since the beginning, we've been using NetApp vFilers that we present through shared networks directly to the customers' MPLS networks for shared storage for all kinds of clusters or their office storage or whatever they need shared storage for. And something that we couldn't do right out of the box with SolidFire. So we've been working with Mike and with ShapeBlue to write a CloudStack plugin so we can do roughly the same thing with SolidFire. And you.
Thanks, Alex.
So as Alex mentioned, I'm Mike Tukowski. I work at SolidFire in Boulder, Colorado in the US. I've actually been involved with CloudStack development for about 3 years, which is the entire length of my time at SolidFire. I think I mentioned briefly this morning at the panel that my first day at SolidFire was literally getting my laptop and getting on a plane and going out to the first CloudStack collaboration conference in Las Vegas. So I've been about 3 years ago, I guess that happened in November, 3 years ago. So I've been doing this for a little while. Just to give you a little bit of background as we walk through the presentation on what SolidFire does, I think that'll help out as far as understanding the use case here. So as Alex mentioned, we develop an all-flash array. It's a scale-out technology, so what happens here is you start with a collection of loosely coupled nodes, typically 4 or 5, and then as you need additional performance or capacity, you acquire additional nodes and integrate them into your cluster, making the overall performance and capacity of your cluster increase. You carve volumes out of this cluster as you would expect. We use the iSCSI protocol or fiber channel protocol, depending on what your interests are there, to expose those volumes. And then we use a whole bunch of efficiency technologies to get the cost per gigabyte to be down to be on par with traditional disk-based SANs. So compression, deduplication, thin provisioning, this is all done in line and is just a natural part of the way the system was designed, so you don't really have to think about it. And then from my perspective as a CloudStack developer, that bottom point is really important. There is a REST-like API that's exposed from the SolidFire cluster. One of the nodes is always exposing this API and making the API highly available. And this allows me to control all of the different aspects of the system. So any kind of management activities that you can think of, creating volumes, creating accounts, deleting volumes, creating access control lists, all sorts of stuff that I need to do through CloudStack can be orchestrated through the REST-like API. And I make use of this not only in the storage plugins that I've developed for CloudStack, and there's 2 different SolidFire storage plugins, but then also with these new plugins that we worked on with Interroot In this case, there's two GUI plugins, and then there's what's called an API plugin. So the API plugin is it's actually a very nice feature in CloudStack that you can develop those kind of plugins to take CloudStack's API and extend it to do additional functionality that might be specific to your third-party needs. So in this case, maybe we need to make a VLAN on the SolidFire cluster. In this case, I can actually create that functionality through an API plugin and then make use of that through our GUI plugin, and that just lives within the CloudStack management interface. It looks like a normal part of the system. So we'll get into more details as we go through the slide deck here, but just at a high level, what we're looking at is two GUI plugins. One is for administration purposes, and then one is for everyday users, people who want to make volumes and delete volumes and things like that. And then the single API plugin, which supports both of those GUI plugins. And I guess just to point this out, even though we make use of that functionality through GUI plugins, these are normal CloudStack API commands. They can be invoked through any of the normal mechanisms that you're used to, including tools like CloudMonkey that Rohit had developed, or anything else that you're familiar with. So let's kind of walk through here, and then we can kind of double team this. Let's see. All right, so what we see here is at the very bottom, so this is the CloudStack user interface. And I've actually enabled the two plugins that I developed, and we can see at the very bottom, what happens is you have an extra tab just called plugins. If you click on that, you can see all of your available plugins. As an administrator, I actually need to do things like create references to SolidFire clusters, create VLANs. That's a need in this particular use case that we had. So we have to be able to not only make references to SolidFire clusters, but also be able to create VLANs. Obviously be able to delete these objects, edit these objects, view some of the properties of these objects. And we want it to look just like any other part of the traditional CloudStack GUI. So an administrator actually has access to do those administrative tasks through the bottom plugin right here. I'm alive. And I've actually never done that before. And then the top plugin is for the normal users, but also administrators can use them as well. Did you get that on video or something? Great. That'll be tweeted out now. So you've got these two GUI plugins making use of the same API plugin. And let's go ahead, and I think we've probably got about 20 minutes to walk through these, and then Alex, just jump in where you see things to comment on. Otherwise, I'm going to kind of walk through and show you what the plugins look like. So actually, let me go back here. Pretend like we're an administrator. We've decided to click on that SolidFire administration button, and that will take us to this tab here, which is just pretty much, it looks the same as any other table in the CloudStack GUI. In this case, it's actually presenting us with a list of SolidFire clusters that we're interested in. So in here, in this case, I have just a single one that I've listed in the table. Now, we want to go ahead, maybe we have, in Alex's case, you have how many data centers now? You have 13 data centers?
14.
14
yes.
data centers. And they each have their own SolidFire cluster. So he might want to go through and then add those SolidFire clusters into this table to make them available to the plugin. And without stepping off the stage this time, I will point to the button up here. You can see it just says add a reference to a cluster. So Alex would go in as an administrator, click on that button, take us to the next page here, where we're actually able to provide information like the IP address. We're calling it an MVIP, that's a management virtual IP address. So that's a SolidFire term, which in this particular case is completely useful to have there because people who use SolidFire systems would, for the most part, understand what an MVIP is, or a storage virtual IP address. In this case, this is the IP address that we want the plugin, the API plugin, to send its storage commands to. So you can picture the SolidFire cluster as a collection of storage nodes. Each one has its own IP address. One of them is hosting this management virtual IP address. If that node goes offline, another node will pick up on that virtual IP address, which will be completely transparent to any of the clients, like the plugin, that are making use of that particular SAN. So that's our IP address, our management virtual IP address. Then we just specify things that you're probably expecting, like a username and a password. So this particular username, I had to go into the SolidFire system ahead of time and create a user called admin, provide a password. And then here, this is where I'm actually just referencing that. So at this IP address, this username, this password, this is what we want to be able to talk to. The other pieces of information are around quotas. So trying to control off of this particular SolidFire cluster how much capacity can be drawn from it, and how much in terms of IOPS. So again, I'm going to be careful here. The capacity here, we see 10,000. This is in gigabytes. And I forget offhand if that's reckoned in base 2 or base 10, but it's consistent with how CloudStack does it. So 10,000 gigabytes we can use from this SAN. If we ever create a volume that goes beyond that, we'll fail that operation. The other parameters here around quotas are around the minimum, the maximum, and the burst IOPS that you can draw from that SAN. So with a SolidFire cluster, what happens is when you make a volume, as any storage system, you provide a capacity for the volume, but you can also specify performance characteristics very specifically. You can say that I want maybe a terabyte volume, and it needs to have 1,000 4K IOPS as a minimum guarantee. So if I'm pushing the system hard enough, I absolutely need that 1,000 4K IOPS to be available to me. Maximum is more like kind of like a rate limiting concept. So you might say maybe I'd like to typically rate limit them at 2,000 4K IOPS, but we have this kind of fancier QoS implementation where you have this concept of burst as well. So not only do you have a minimum guarantee and what's typically a maximum, but if you're not hitting your maximum all of the time, you're accruing credits, which means that if you do need to burst above your maximum for a short period of time, which is typical for a lot of applications, we won't constrain you to that hard maximum. We'll let you burst above, either finish your operation or expend your credits, and then you can be brought back down between your maximum and minimum IOPS. So here what we're saying though is, at an aggregate level, from the SolidFire SAN's perspective, make volumes to your heart's content until you hit any one of these quotas.
Yes, and SolidFire is a little bit faster than 1,000 IOPS.
Yeah, sorry, I don't always put in like realistic numbers when I make my screenshots, but in my case I had, well actually we were talking about this morning as well. I had a virtual system which isn't a full-blown SolidFire system, and so I had a smaller number of IOPS and a smaller capacity at my disposal. Now you can actually do you can actually over-provision those numbers as well. So if you want to put in much larger numbers, maybe you don't really want to constrain somebody, you can just put in large numbers and actually over-provision not only the capacity, but also the performance of the system. It's only when you have not over-provisioned the performance of the system that your minimums are guaranteed. Otherwise, of course, you could just throw in ridiculously large numbers and not have the IOPS to back that up with.
Yeah, as a general rule, usually a good idea not to provision the minimum, then over-provision maximum and capacity.
And another reason I put in such small numbers, it was easier to test. I could make volumes manually for a little while and make 100 gigabyte and then make another 100 gigabyte and eventually hit that limit or performance limits and things like that. Typically what you're going to be looking at though is you start a SolidFire cluster with 4 nodes. They're either 50,000 IOPS or 75,000 IOPS, and then varying capacities. And then as you want to, you grow the cluster out. You don't have to have the same exact model. You can have a newer model with more IOPS or more capacity. You can kind of customize the performance and the capacity as you grow out the system. So, all right. So now that we've got that, that's one quota. We'll see another type of quota as we move through this. So here we've gone ahead, we've hit the OK button. Now we can see we've got an extra cluster in our table. So now the plugin has access to 2 SolidFire clusters. And we can see in a bit how that will actually be useful. So in Alex's case, it sounds like you have a single cluster at each site.
1 cluster per zone. Yep.
Okay, 1 cluster per zone. So he would still kind of specify here the location, or actually the information for the cluster. Let me actually go back a slide. Yeah, and I actually didn't point this out, and that reminded me. The very top row is availability zone. So you could imagine in Alex's case, he's got 14 zones, each with a single SolidFire cluster. He's going to be picking a different zone for each one of these clusters. And I don't have any restrictions in place here, so even though it takes a while to grow out a SolidFire cluster, you'd have to be up around 100 nodes. But let's say you hit that someday, you can start another SolidFire cluster in one of your zones. You can have multiple SolidFire clusters in the same zone. Cool. I forgot about that availability
in our case,
zone.
limitation is more likely to be switch pods.
Yeah.
Long before we reach 100.
Yeah.
So,
and if you definitely, that's good points. All right, so these are our SolidFire clusters. Like any dialogue, I guess, in CloudStack, you can go into the details for the particular object, and this should look just like everything else you're familiar with, whether you're looking at volumes, snapshots, anything like that. You can't really read this a whole lot. I tried to stretch it out, but it just has information like the name, the CloudStack ID, zone, MVIP username, all of the stuff that you input in the dialogue. Is available here, and then some of the information can be modified. So if we were to go into edit mode, just like there's a delete, I guess I should probably just hang out over here. There's a delete right here, and of course that does not actually delete your SolidFire cluster, that deletes the reference to the SolidFire cluster, so I do tend to try to emphasize that in the text. And then there's the edit button, and if you click on that, you can see that it's very difficult to see in this particular screenshot, but in normal edit mode, these are text fields, and you can go into this area here that I've circled, and you can change those values. So let's say Alex decides that his SolidFire cluster really does have more than 1,000 IOPS. He can add a few extra zeros on there, and then just at the bottom hit the apply button. If you go up in size, so add some zeros on, no problem. Even if you don't technically have that capacity or performance, we'll allow that to happen. If you go down, the system will actually check to make sure that if you have any volumes that are currently in use, that reducing any one of those numbers will not then have put you over what you should be. So for example, let's say I got a single 100 gigabyte volume, and I reduce this number to, say, 10 gigabytes. The plugin will complain about that. You don't have enough capacity to support your existing 100 gigabyte volume. So you can do your normal view operations, your normal edit operations. You can delete as you'd expect. Once we have this in place, the next piece here is around virtual networks. And maybe Alex can explain how you're using virtual networks.
So currently, I don't know how everyone's familiar with vFilers, but on a NetApp fast filer, you have vFilers, which are basically storage VMs that run directly on the NetApp, where you map a vFiler to an IP space to a VLAN interface. So the IP space is the routing space that the vFiler has, which is something that SolidFire doesn't do yet. And then we map that to a VLAN, and we create a shared network on the same VLAN. So that shared network, we also connect to our core, to the customer's MPLS circuit. So they can attach that storage network directly to their VMs in that zone, or to VMs in other zones, or to other vFilers in other zones, and use things like snap mirrors. So in this case, we need SolidFire to do something similar. One problem we have with vFilers is that all of this is done manually. There's no nice GUI or anything. We do use some WFA NetApp automation to do the vFiler provisioning, but the CloudStack part, we still have to do by hand, create the shared network, etc. With this, yeah, this plugin will do everything for us.
Cool. So this is the area. So remember, again, this is an administrator doing this. He or she has set up a couple references to SolidFire clusters. And then maybe actually going to skip back a couple pages here. What you normally do in CloudStack, if you're not familiar, if you want to go and view the details, you actually just click on the row that you're interested in. I think it's usually the name column. And so you can picture that would take us here. Now you've got our details. The next step would be in the upper right, you can view virtual networks. Like for example, if you were looking at volumes and you're on a volume here, you would have the option of view snapshots in the upper right. So in this case, we can view virtual networks. We click on that button. I'm going to skip past that. And that takes us here. And we can see right now it says no data to show, which is just kind of a common piece of text that we display in a table if we haven't actually created any of those objects. And what we want to do is actually go over to the upper right here and add a virtual network. And that's the next slide. And it's very similar to what we just did with adding a reference to a SolidFire cluster, but of course the details we specify here are going to be different. In this particular case, the account needs to be selected. So for Alex, you're doing a single
account per domain. So account domain is the same thing, and then a VLAN which maps to the customer's storage VLAN.
Okay. So Alex is doing a single account per domain, and then a single VLAN per account, at least for now. We decided we could scale that to multiple VLANs per account, I believe.
Yeah, we have some customers have several storage VLANs.
Okay. So it could be multiple VLANs per account. Right here, we're just making a single virtual network. And so we just pick the account that it's associated with. If we wanted to go make another virtual network and put it in the same account, we just make sure that we pick the same account. Provide a name for the VLAN, the tag, all the information that you would normally have to provide from a networking standpoint. And then we hit the OK button. Once we hit OK, we're going to see the information, well, it's been added to the SolidFire system, and then it's also visible in the CloudStack GUI through the plugin in the table. So we're back to kind of the same table that we were at before. And now we can see we have a single virtual network for this particular cluster that's available to us. In the future, what we're going to do is our users are going to create volumes, and they're going to pick which VLAN they want their volume to be on within the constraints of the account. So if their account only has 2 VLANs, they can pick the VLAN it's on. Did you have anything to add?
Yeah, which implies selecting which shared network.
It's very similar.
Yeah, and this the SVIP, just the service VIP, where data is actually served. So each SolidFire node gets an IP on that network plus the VIP.
Yeah,
so exactly. In our case, we'll leave 40 IPs, so we can grow our cluster up to 40 nodes, and plus the service VIP.
Good point. So actually, in that previous slide, what we can see here is the start IP address. This is the first IP address on that VLAN that can be assigned to one of the SolidFire storage nodes. So you can build out a SolidFire cluster to 100 nodes. In that case, you would need at least a size of 100. Here we're saying we can start at this IP address, and we can use anywhere from 1 through 20 and assign those IP addresses out for the VLAN needs of that particular storage node. And then as Alex adds additional storage nodes, they can take up the remaining IP addresses in that space. And then if he decides he's actually going to be adding storage node 21, he can go in, if he still has the range available, and expand that number to be 30 or 40 or something like that. And then this is the storage virtual IP address, which is very much like the equivalent of a management virtual IP address. It's an IP address that floats on one of the nodes in the cluster, and when you go to log in through iSCSI, that's the address that you initially talk to, and then you'll be load balanced out to one of the other nodes in the cluster for actual I/O operations. So now we've got our VLAN, and let's see, I'm going to move ahead one slide here. Okay, so we can actually just click on that row again, take a look at the details. This is pretty much just as you would expect in any other object in CloudStack. The only thing that you didn't see before was the ID of the virtual network in the CloudStack database. And I probably should point out that using this plugin requires the addition of 3 extra tables in the CloudStack database. There's the cluster table, virtual network table, and then there's a volume table. And that's where we're getting these IDs from. So we still uniquely identify everything the way any other object in CloudStack is identified through these UUIDs. All right, so then we just want to see here, we can of course go ahead and delete or edit this virtual network. We're going to go ahead and edit it. And again, you can't really see the text field here, but the areas that I've circled are the areas that you can actually edit. You can change the name of the VLAN, you can change the net mask, things like that. Hit the apply button, actually make that take place on the SolidFire system, and kind of away you go. And okay, so now we've got our clusters added. We've got our virtual networks added for each of our clusters. The other quota that we want to take a look at is on the account that is going to be involved, the accounts that are involved in this system. So as Alex was mentioning, each account is for a different tenant, and it sounds like you would want to be able to provide different limits to
depend on each customer.
Yeah, and maybe that's based on what they pay and things like that. So in this case,
how loud do they ask for it?
And how so we have our quotas in place to protect usage on the SolidFire clusters. This is the equivalent for the accounts. So we can say for this account, their capacity can go up to 100,000 gigabytes. So let's say they make a volume. It can either be failed because it went over that 100,000 gigabytes limit, or if the only cluster or clusters that was available to it don't have a sufficient amount of space because of their quotas, this operation can be failed as well. And not only from a capacity standpoint, but of course from a performance standpoint. You also, when you create a volume, you'll specify the name, the size, and then the 3 performance values, the minimum, maximum, and burst IOPS. And if any of those exceed the limits in your account or on the available clusters for you, that's when the operation would fail. All right, cool. So this is kind of switching gears here to the user's point of view. Now that Alex has set everything up from a cluster standpoint, from a virtual network standpoint, it's off to his users to actually make use of the system. Ultimately, what the users want is volumes that they can create on the SolidFire system and then reference them from multiple virtual machines simultaneously. And what was your main use? Was that like a SQL server?
Yeah, MS SQL.
Okay, like a quorum disk? Or,
Yep.
Okay, so in this case, it's like a quorum disk. We need multiple virtual machines to have access to the same disk at the same time. This is something that CloudStack does not currently enable. You can't actually attach a volume in CloudStack to multiple VMs at the same time. So there's a couple ways you could solve that. You could go into the CloudStack code base, of course, and make that happen. We had some limitations in terms of how we implemented it, in that you're on version 4.3, moving to 4.5. We didn't really have the ability to go in and make these modifications to CloudStack. So we implemented this in the form of plugins. And so that's why this code wasn't actually directly thrown into the CloudStack code base. And kind of exists in the plugin realm. So as a regular user, you're going to go into the plugins tab when you first log in, click on the plugin that's available to you. As a user, you can just click on that one. And you'll see this table here in the beginning. There's no volumes, no data to show. In the upper right, just says add a shared volume. I know it's called shared volume, and that's the main use case here, like a shared quorum disk. But there's no reason you actually have to have the volume shared among virtual machines. It's just that that's the main use case here, so that's just kind of how we labeled it. But you'll click on that add shared volume. You get your dialog here. In the way upper area here, you pick the zone, and that's going to limit then which clusters you can use. So in Alex's case, he's just got a single cluster per zone. So by picking that zone, you've pretty much picked the cluster. Although the actual user doesn't care what cluster everything is stored on, and that information isn't exposed to him. You can give a name to the volume as you'd expect, size, minimum, maximum, and burst IOPS. And then if you are an administrator like Alex is, Alex can actually make a volume in a particular account. So he could make it in his own account, he could make it in the account of somebody else. If you're just a regular user, then you won't even see this row. It'll just be invisible. You can kind of picture it like a combo box where your account is selected and there's no way to deselect it. And then at the very bottom here, you can, if you have multiple VLANs that are available to your particular account in that particular zone, those will be visible there, and you can select either one. Now, I don't know, is it going to be common, do you think, that people will have multiple VLANs here, or do you think that...
Multiple virtual networks, it will happen, yes.
Okay. So we wanted to make it available. Maybe for a lot of people, they won't know what this means, and there'll only be one option, and so they just leave it. And then for the ones who do have a need for multiple, they'll have multiple, and they can pick it. So great, and basically the VLAN here is going to be associated with one of your SolidFire clusters. So if you did have multiple clusters in that zone, that would be the kind of ultimate determinant of where your volume is going to land. So once we hit the OK button, we can see we've got the information in our table here, just like the other examples. On the name column, we'll click on our volume name and move over to the viewing of the details. Pretty much no big surprises here. There's a lot of information actually, and a bunch of it is cut off. A bunch of the fields at the bottom would be something that would be of real interest to the end user. They would want to know the target portal, so the storage virtual IP address. I think I just refer to it as a target portal since that name is more common to people. They want to know the IP address. They want to know the IQN of the volume. And then they can take that along with the CHAP credentials. So at least those 4 pieces of information. They can then take that into their virtual machine, and then whether it's running on Windows or Linux or whatever, they can directly set up their connection to this volume. So that way too, you can avoid the hypervisor in terms of LUN limits and things like that. You just directly connect up to the volume through your VM. And so in Alex's use case here, he'd have SQL Server instances, pointing to these, pointing their quorum disk to the same volume, and then they can be HA. And then as you'd expect, of course, there's a couple fields that you can go into edit mode. So you can, of course, delete the volume. You can go into edit mode. If I click on edit mode, there's 4 fields, really just the capacity and the 3 performance values that you can switch. If you do make changes to these, of course, we're going to be checking this, validating this on the management server side. So if you change the size in gigabytes, maybe you change it to 100,000, well, when you send that information to the API plugin, it's going to check with the SolidFire system to make sure that you do actually have, well, actually, it's going to check to make sure it doesn't exceed your quotas. And if it doesn't, it will submit the operation to the SolidFire system. Same thing for the performance as well. Let's see. We hit the apply. If we want to change something, that changes the value. Eventually, you come back to the normal table with your new values. I was going to show one more thing here just to kind of clarify this. Let's see. Or maybe... Well, it was really more like information on how VLANs fit into this, but let's see. It's just on a different slide deck. Presentations, Dublin. Oh, that's not it. One more. Here we go. Okay, here we go. So, this is just kind of a visual on what we were going through there. You can picture, you've got your hypervisors, you've got your VMs. Each of your VMs belongs to an account. In this case, the ones in blue, they both belong to account A. And they're going to be on their own VLAN, connecting up to, say, just this one volume. Of course, they could be connected up to multiple volumes as well. And then on the same hypervisor, you can have another VM from a different account, as you'd expect, and it will be on a different VLAN connected to a different volume. And this just kind of illustrates that you don't have to have VMs sharing a volume. If you wanted to, you could, of course, have them have their own volume without really the concept of sharing, as in this particular quorum disk example. You also, and I didn't have a slide for this, you would want to go into network offerings and make sure that you have, that CloudStack is aware of the VLANs that you're making on the network and on the SolidFire system as well. So that way, both CloudStack, SolidFire, the network, they're all kind of in sync. Did you have anything you wanted to add to that, Alex?
Not really. At the moment, we are using CHAP for authentication because the volumes are actually presented on all VLANs. But yeah, something that SolidFire is working on, that they will be properly pinned, and hopefully at some point, each will have his own routing domain as we have on vFilers. Yep. Because that does help us. A customer can just have a volume in a data center and present at a remote office or anything.
Right, yeah, exactly. Cool. Were there any questions? Anybody have any questions about this? So, all right, well, thanks a lot.